Okay, we're going to look at section 7.4, question number 18, because I had several students ask me, particularly when you get to these numbers down here, how in the world do we get those numbers? Well, first of all, if you look at the question help, it's going to tell you to use technology, which we'll look at in a second. But the main problem is when you get to the population standard deviation is when you kind of need help. In this situation, we are looking at the heights of basketball players, and we are being asked to calculate on A, the mean and the standard deviation of the actual population. So this population is about, I believe, 60 players. To calculate the mean, you could go ahead and just open it in StatCrunch. We can do the first part in StatCrunch quickly. But notice that we're wanting the mean to be rounded to 1 decimal place. So we're going to do summary stats, columns, variable 1, compute, and all we're going to get from this is the mean. Notice that the standard deviation is calculated without rounding. They are wanting us to calculate the standard deviation using the mean that we rounded to, which was 69. We're going to round to the 1 decimal place, the tenths place, so our mean is 69.7. Close that out, you won't use it again. And then what you want to do is, I'm not going to click on this because I've already opened it, but you want to open in Excel, you want to click on that and give it a few seconds to actually open and load to your spreadsheet. So what it's going to look like when you load is you're just going to have the first column. You're not going to see all this other stuff. But I have to take the column and calculate the standard deviation. Remember, you should know the steps to calculating the standard deviation. You're going to take each individual number and subtract the mean from it and square it and add all those numbers up and then divide it by your n, which is 60. So what I did was I put the mean down here. This is the population mean. It's also right here. Okay, so I set up my formula, and this is strictly just to do for the homework. You won't have to do all this for the test. You won't have this complicated of a calculation with 60 numbers. But what I did was I set my formula as equals, and then I clicked on the cell, and then I put minus 69.7, and I press enter, and then I just copied the formula on down. Then I clicked on this one and I said equals, and I did this cell times this cell because I'm squaring it. So this number B2 times B2, and then I copy the formula on down. To copy it, you just click right here and you copy it on down. Now, once you get your difference of your x value and your mean squared, you're going to take a sum. You're going to say equal sum and add these up. And then you're going to get your variance, you take the sum, and since this is actual population, you don't divide by n minus 1. You actually divide by n, the population. To get the standard deviation, you take the square root of the variance. So here is our standard deviation. But if you remember, it wants the standard deviation, I believe, rounded to 2 decimal places. So there is our standard deviation for our population. So these two numbers here are for your population. That's the first step. Here's the hard part. This has many steps to it, okay? First of all, we have to see, if you look at your question help, it will walk you through it. We've already done A, but we have the central limit theorem, okay? If our sample size is more than 5% of the population, then we have an extra calculation to do. So our sample is 45 and the population is 60. If you divide 45 by 60, you're going to get 75%. That is definitely bigger than 5. So what we're going to have to do is we're going to have to use this formula here. What does all of this mean? Big N is the population. We know big N in our problem, there's 60 players. Little n is 45. And the standard deviation is 4.49. Those are the three numbers you need to calculate our standard deviation for our sample. Okay? This is an extra calculation you're going to have to do. I have it set up in Excel. Let's look at it real quick. So I know big N, you need to know all these things before you start plugging in numbers, okay? We know what the population standard deviation is, population mean, but we don't know what the sample standard deviation is. So how do we find that? Well, first of all, I did 4.49, the standard deviation divided by the square root of n. That was your first part of your formula. So I broke it down into 2 steps. So that number is going to be 0.66933. Now I'm going to do the second part, which was the square root of n minus n divided by n minus 1. We know n is 60 minus 45 would be 15, and 60 minus 1 would be 59. So the square root of 15 divided by 59 would give us this number. Now we have to multiply those two numbers together, because look at your formula again. You have to get this number and multiply it together. And then that is how we got 0.337489. So that number is our sample standard deviation. If I can get it, if I can copy that over, I'm going to keep all of my information together here. So basically we calculated these numbers, and we needed all 4 of these numbers. We needed the population means, population standard deviation, big N and little n, to get the sample standard deviation. And you would think that you would be through, but no, we're not. Now we have to calculate the z-score. That way we can get working on our probability. So how do you get the z-score? Well, once we did those calculations, you want to get the z-score by taking, what is the x with the bar up under it? That's the sample mean minus the population mean divided by the sample standard deviation. So our sample mean minus population mean divided by sample standard deviation. How do we know this is a sample? Because it has that little x bar up under it. X bar is always your sample. The mu is your population. So now that we know that, let's go see how to calculate the z-score. This is not our number, okay? We know that our population mean is this number, and it's not going to change in any of our calculations. And we know we're going to divide it by our sample standard deviation, which is this. The number that's going to change is going to be whatever we're plugging in for our sample mean. So in this particular problem, so this is what we're doing to get the z-score. So we're looking at 69, okay, for our sample mean. What's the probability that our sample mean? So we would put 69 in here. 69 minus the population mean, which is 69.7, divided by the sample standard deviation, which is 0.337489. So if you press enter, you will get the z-score is negative 2.074. That is not our answer. That helps us calculate the probability. Now, if you look at your directions here, or view an example, it's going to tell you to use technology. Let me go down to where we were. Okay, use technology. Don't use the table. If you were on the test, you would have the z-table in front of you and you would look up the z-score and find the probability. But here it wants us to use technology. So what we want to do is we want to do the normal distribution, and we want our z-score to be this, so I've highlighted it, and we want it up to that point. So what this answer is going to give me is z, the probability that z is less than or equal to this number. So we get 0.0190. 0.0190. So we were okay with that problem. Okay. Now for the next one, it's a little bit tricky because the number we're calculating is going to give us up to 70.5. So this time all we have to do is change 69 and put 70.5 in there. So our z-score is 2.37, and it automatically changed because it's whatever number I have here. So the probability, we want to know that what it is greater than. Okay, so we want to know what it would be greater than. This number tells me what it would be if it were less than. So what we want to do is, we know the whole is 1, and we want what's above, the probability above this. So we will, when we're doing more than, you do 1 minus this number, and we get 0.0088, which is what I got. Alright, so for between, if you want between, you get the probability of the first number, the probability of the second number, and you subtract out the probability of the first. Because here's your curve. Okay, your curve's right here. You want everything in between here. If you get the probability of this number, this is everything behind it, even including what is before 69.5. So we have to subtract out the area of the probability up to this number. So here's what it looks like. First, we're going to do the z-score. We're doing between 69.5. So first, let's get the area of 69.5. So we know the probability that x is, let's say, less than 69.5, we know that that is 2.7672. Okay, 2.7672. So let's remember that number. Now let's change it and do the probability of 71. And this time we get 0.999941. So what we need to do is we need to take the probability all the way up to 71, which includes the probability of 69.5. We want to take out the area before we got to 69.5. So what we do is we take the difference, and that will give us the area in between, which is 0.7232. So if you're looking for the probability of it being less than, you always use the number that you get. If you want to find greater than, you have to do 1 minus that probability. If you want to find in between, you have to take the biggest one and subtract out the smallest one. This was a very tough and challenging homework problem, and hopefully knowing how to use the technology, hopefully that will help.